Hello everyone and welcome. Today we have an interesting question on sound waves. Without further ado, let's do it together. The question reads, a speaker emits a sound of power 10 watts. The sound spreads uniformly in all directions. A. What is the intensity of the sound at a distance of 5 meters from the speaker? And B, what is the loudness level in decibels at this distance? This question is very simple. All you need are two formulas. The first one is the formula for calculating sound intensity, which is giving us power over area. So whenever you are asked to calculate sound intensity, this is the formula to use, power over area. Power is measured in watts. We already have 10 watts already. And with this 5, we can calculate the area. I'm going to show you how to do that. And the next one is the loudness level, which is the decibel, is equal to 10 log base 10 multiplied by the sound intensity over the threshold of human hearing. All right, these are the two formulas that we need to know. This I naught is called the threshold of human hearing, and it is a constant. So the value is 1.0 times 10 to the power of negative 12 watts per meter square. So it's called the threshold of human hearing. It's a constant value, just like acceleration due to gravity is a constant value. Now let's go ahead and find the sound intensity first. Right here, we have that the sound intensity is equal to power over area. So we continue from here. Intensity is equal to, the power here is 10 over, so in this case, based on the inverse square law, area is given as 4 pi r squared, where r is the radius. Okay, so let's substitute what we have to solve it further. Right here we have that the intensity is equal to 10 over, we have a 4 pi, and our radius is 5, and then we square it. So we continue, this is 10 over 4 pi, and then we have 5 squared is 25. Okay, let me write that nicely. We have that intensity is equal to 10 over 4 pi multiplied by 25. This is better right now. So we can now use our calculator to simplify. So pi is given as 3.14. So we say 4 times 3.14 times 25. I'm getting 314. So we have that this sound intensity is equal to 10 over 314. And when you simplify that further, 10 divided by 314 is giving me 0.0318. So the sound intensity is equal to 0.0318, and the SI unit is watts per meter square. So this is the sound intensity. Now let's now calculate the loudness in decibel scale. So this is our part B. We say the decibel scale is equal to 10 log base 10, and this is multiplied by the sound intensity, which is this. We've already found the sound intensity, over I naught. I would say, yeah, this is I naught. which is called the threshold of human hearing. I already gave us the value, which is 1.0 times 10 to the power of minus 12. Let's solve this further. Here we have this to be equal to 10 log base 10. We open our bracket. Our sound intensity was found to be 0.0318 over, and right here, our threshold of human hearing is 1.0 times 10 to the power of minus 12. Then you close the bracket. So let's go ahead and solve them to see what we're going to get. Right here we have 0.0318 divided by 1.0 times 10 to the power of minus 12. What are we getting? I'm getting 3.18 times 10 to the power of 10. So we say the loudness level is equal to 10 log 10 multiplied by 3.18 times 10 to the power of 10. And then when we take the logarithm of this, we have 10 log 3.18 times 10 to the power of 10. Okay, so I'm getting 105.02. So by default, the logarithm scale is to the base 10. So you don't have to worry if your calculator doesn't show you a base 10. Just type 10 log, okay, 10 log this, okay. Since we've already simplified it to be 3.18 times 10 to the power of 10, just type on your calculator 10 log, then the value in the bracket, okay? So don't bother looking for 10, because by default, it is to the base 10. So the loudness level is equal to 105.02 decibels. Okay, so this is the answer in decibel scale. See you in the next video where we shall be solving more problems on sound waves. Thank you so much and bye.